Right, today we're going to just do a quick revision sheet for a test that we're doing at the end of this term in the Michaelmas term of 2020. So our first question is about the normal distribution. We'll discuss whether the following variables will be normally distributed. A, the time the students take to read a novel, or B, the amount spent on the groceries at the supermarket. So pause now if you're watching this recorded later and like to have a go at it and think about it. So A, what is likely to happen is you're going to find that there'll be some really fast students, and then eventually you'll get to sort of where most students finish, and then there'll be some that will take a lot longer to read the novels. So we get what's called a positive skew here with part A. So therefore it's not a normal distribution. Whereas B, the amount spent on groceries in a supermarket, we're likely to have them grouped around an average value because most people are going to eat the same amount of food each week. And therefore, that's going to mean that we're going to be probably more evenly distributed around a mean value. So therefore, we're going to get a normal distribution. Right, question 2 here. What we're going to do is we're going to try and sketch on the same set of axes normal curves for these 3 normal curves. So you've got one with a mean of 5 and a standard deviation of 2, a mean of 1 and a standard deviation of 4, a mean of 0 and a standard deviation of 1. Again, pause now if you want to do this question at a later date. Right, okay, so let's just go through this question now. Sorry about that. I was just trying to capture some graphs of this I'd drawn before. It's not going to be easy to do. Didn't quite work out how I expected, so what I'm going to do is I'm going to draw them on the fly. So we're going to have a mean of 5, and now the standard deviation of 2 is going to be exactly the same. So you can see where this graph, actually what's quite nice, because the mean is 5 and the standard deviation of 2, what I do is I just draw on top of this graph, my graph, I'm just going to show my standard deviation coming down at 2 points away. Then what I can do on my app is I can just select that drawing. So I missed it. Let's try again. Select that drawing and then just move it so that it is 2 along. So here we go. I've now got my mean is now at, undo that. I've got my mean is now at 5, and my standard deviation is still going to be 2, so therefore the inflection point of the curve is still 2 apart. Now what I'm going to do is I'm just going to copy that picture again and then adjust it. Copy that. Let's just move over here and just paste it here, and then I can bring it back onto my curve. And what I'm going to do is I'm going to put it on. I want a mean of 1 now. So I'm going to put the mean at 1. Okay, now my standard deviation is 4. So this actually is going to, this point here is going to move an extra 2 down. So what I need to do is stretch this out a bit. Let's just move that down. Standard deviation is 1. I've now got it down to about, so I've got a standard deviation of 3 going on there. I've got a mean of 1. There we go. No, not mean of 1 there. Mean of 1. So the mean is at 1. And then 1, 2, 3, 4. The standard deviation is now down here. So that's what a graph, that's going to be my answer to A. There's my answer to A. There's my answer to B. I want my answer to C. So I want to have a mean of 0 and a standard deviation of 1. So I've got to bunch it up a bit. So let's just paste another one and just bunch it up a little bit. See what happens. Bring it over. And I want to undo that. Select that all again. Let's try again. Try all of that and bring it across so the mean is now at 0. And I want a standard deviation of 1. I'm not far off it actually. bring that in a touch. There we go. We're roughly at a mean of this one here. Okay, I've got C, which is normal distribution. The mean is 0 and a standard deviation of 1. There's the mean. And what we can see is its standard deviation is just about 1 away. Okay, that's how we do that one. Okay, the amount of juice Simon squeezed from his lemons, normally distributed with mean 35 milliliters and standard deviation 5 milliliters. Copy and complete this curve. So you should be able to list all these points on the curve. I'll add that each of the, well, give you just a few seconds to have a go at that and then to have a go at B. Pause if you're watching this later. Right, so we've got our mean is 35. Our standard deviation is 5 is where the inflection is. So that's going to be 40, that's going to be 45, another standard deviation, and another standard deviation is 50. There's 30, there's 25, and there is 20. Now we want to work out what percentage of lemons will produce 25 and between 25 and 35 milliliters of juice. So we're looking for this area under the graph. So if we go into our statistics section of our calculator, go to distribution, go to normal, and we want NCD. And we're going to set our lower value at 25 and our upper value at 35. And we've got the standard deviation and mean already put in. And we get a probability of 0.477. So for part B, part 1, if we say that X is normally distributed with mean 35, standard deviation of 5, I always think it's important to list that. Then what we get when we've got the probability that X is going to be bigger than or equal to 25 and less than or equal to 35. And that's going to be equal to, and it's asked for the percentage, so we give it as a percentage, 47.7%. Part 2, we want the probability that we want at least 45, so we want X is greater than or equal to 45. So we're now looking for this region here. And we can see it's not going to be very high. So let's exit this and put in our lower value at 45. And all you're going to need to do for the biggest value is you just need to put it as a very large number. Okay. Once you're more than 10 standard deviations above it, you've pretty much got 0. That more than 3 standard deviations that gets you to 99% of the distributions within 3 standard deviations. So it only takes 4 standard deviations really to get down to 0. So just put a ridiculously large number in and you will be fine to get something that pretty much covers all the curve to the right. And we get a probability of 0.02. So our answer here will be equal to, as a percentage, that's going to be 2.28% to 3 significant figures. Right. So just let you read through that for a second. I'm just going to check on my stream. And just check that's all going okay and just see if there's any comments. You can obviously, if you're in the stream, you can ask questions in the comment section. Actually, what I'll do is I'll just move that screen across so as I can see that more easily. Right, so let's have a go at this question. We've got average height of 17-year-olds is normally distributed. So we know that X is going to be normally distributed with mean 179 and standard deviation 8. We always write the standard deviation squared when describing the normal distribution. Okay, and we want to find the probability that the heights are more than 195 centimeters. So we're just going to put this, go into our calculator, put our lower value as 195, keep our upper value nice and big. All right, I didn't put in the standard deviation, which is now 8, and the mean, which is now 179. Now, bear in mind, this is more than a standard deviation above the mean. It's not going to be a very high probability. Let's work it out, and we get 0.02. We've got to do percentage, so therefore it's 2.228 again, same as the last question. B, between x is between 171 and 187. And you can see it just gets a bit repetitive on using our calculator. We've got everything set in. So just do 171 as our low value, put 187 in as our high value. And we get that as 68.3%. Okay, go back, do this one. 163, what was it? 195. And we get 95%. So part C, the probability that it's between 163 and 195. That's probably not far off 2 standard deviations, is it? That gives us 95.4%. Right, our next question. So just putting it more into words, try and work, I'll give you just a chance to pause the video now. Then I'm going to go through it. So I always like to list the distribution. So we've got x is normally distributed, and we've got the mean is 38.6 and the standard deviation is 6.3. And it's a good idea to do this because it means you're showing the examiner what it is you're reading from the question and what you're putting into your calculator. So if you make a mistake in the read, they might see that from your work and give you some follow-through marks. So find the percentages that x is between 30 and 40. So x from here, go into distributions, just remind you how to find it. And we put our low value in, which is 30. Put our high value in, which is 40. Put our standard deviation in, which is 6.3. Put our mean in, which is 38.6. Press execute and we get our probability. And it still wants percentage. I normally don't give probabilities as percentages, I normally give them as decimals. But the questions here are asking for percentages, so we get 50.2%, pretty significant figures. From a sample of 200 oysters, how many would you expect to weigh more than 50 grams? So what we need to first of all find is the probability that x is greater than or equal to 50. So let's do that. So put 50 in as our low value and put a silly number, big, as our high value and work that out. And it gives us 0.351843 as our probability. I missed out a naught, sorry. Let's rub out the decimal point in. So we get 0.035. That's our percentage. So we would expect, go to menu 1, we want to do 0.035184, is probably overkill, 83 times by 200. So it comes out as 200 times by 0.035 and all the rest is equal to 7.036. So therefore expect 7 oysters to weigh more than 50 grams. Okay, last question, we're going to do a normal distribution and then we'll move on, even if I've got more questions on the revision sheet. Okay, if you download this sheet, then you can look up the answers. So we've got random variable x is normally distributed with mean 20.5 and standard deviation 4.3. And what I'm going to do, I want to write out my distribution first. So I get normal distribution, I've got mean of 20.5 and a standard deviation of 4.3 squared. So therefore I want to find the probability that x is greater than or equal to 22. And I'm just going to be able to do this nicely. So menu 2, distributions, normal, cumulative normal, put in my low value 22, keep a nice big high value, oops, press execute again, rather than go down, put in my standard deviation 4.3, put in my mean 20.5, and I get 0.3636. And I think 4 figures for probability when using normal distribution is what the old tables used to do when we used to do these with tables. Is fine. And we want to find the probabilities between 18 and 22. That, put a low value of 18, put a high value of 22, and you'd be surprised if you've got questions like this in the exam where they're just repeating the same thing over and over again, and you get that answer. And we want to find, right, the probability that x is less than or equal to k is equal to 0.3. So what we're going to do, we're going to do something slightly different here, is we're going to do an inverse normal distribution. So inverse, because we've got the probability. Now, if we're less than or equal to k, so here's our k value, and we want to be less than or equal to there. We want to be to the left of there. So our tail is to the left. When you go here, you can choose either left, right, or central. Okay. We know the area is our probability, because that area underneath the graph is the probability to the left of k. So we're going to put our area as 0.3. And we've still got the same mean and standard deviation, which is nice. Okay, and it tells me that k is going to be equal to 18.24. Next question. Okay, we're going to do some differentiation optimization. I just want to grab something first to help you see my cursor more easily. Now there we go. So you can see my cursor more easily on the screen. So we've got a factory makes X thousand pairs of chopsticks per day. Cost of CX equals all of this. Find C of naught. So we just want to put naught into this expression. So put naught into x cubed, you get naught times by that number's naught. Plus 24 times naught is naught plus 5,400. So we get $5,400. And what does this represent? Well, this represents the cost of not making any chopsticks in a day. So this is a cost, or fixed cost, you might say, of not making any chopsticks. So, you know, this could be the rental or salaries they might pay of the people that make them. So, and you've still got to pay them even if they don't make them. Okay, that's a part A. Part B, we want to find C dash of x. So we want to differentiate this. So times by the power, times by 3, we get minus 0.0006x squared. Take 1 off the power. Now here, we just get, remember, x to the 1 times by power just gives me 24. Take 1 off the power gives me x to the 0, which is just 1. Well, most of you will think 24x, what's the great differentiating is finding the gradient. So just what's the gradient of 24x? Well, it's just 24. There's lots of ways to think about how to do this. So what we've got here, so we've got the change in cost for making an extra chopstick. Yep. So this is the rate of change of cost per chopstick. In cost per chopstick. Okay, because when basically this will tell us what happens when we say if we're making 1,000 chopsticks at this moment in time, that will tell us that how much the cost is going to change if we just add on one more chopstick at that moment in time. Okay, and we're going to create a bit more space. So we want to do C dash of 1,000. So let's go exit, menu 1. So we do minus 0.0006 times 1,000 squared plus 24. And it gives me minus 576. So we've got C dash of 1,000. Sorry, so it was 100, not 1,000. Let's go back and just change that. Go across. That did seem a bit weird. It was minus. So always check back when you've got a strange answer. So we've got 18. So the cost. So the rate of change of cost at this moment, when we're producing 100 chopsticks, this is the change in cost when producing the 100th chopstick. Just create space in here to write this down. The change in cost when producing the 100th chopstick. Find the actual cost of producing the 101st lot of 1,000 chopsticks. So basically, so therefore, what they're doing is, so you go at 100, they can say, well, okay, your rate of change is going to be 18, so therefore you'll be adding on 18. We're going to find the actual cost of producing the 101st chopstick. So what we need to do is we need to put the 100th one in, and then we need to put the 101st into this formula. Okay, so let's just put those into our formula. So let's get minus 0.0002 times. Actually, what I'm going to do, I'm going to show you a little trick. So what I'm going to do is I'm going to put 100 in, press execute, and then I'm going to put the answer into this. So when you know you're going to repeat something, so I'm going to do this with 100 and 101. So therefore, I put shift answer. I'm going to be to the power of 3 now, plus 24x. No, x. It's not x now. I could have used x instead of answer. I could have made 100 equal to x. There's another way of doing it. I've used the answer button and press execute. So I've got there. Just make more space here. So I've got the 100th cost of the first 100. I think it was the cost of producing 100. No, the cost of producing 100 sticks is equal to 129,598,100. Okay. And now what I'm going to do is I'm going to go back up through my calculator and change this value to 101. And what I get is I get 130,89393.94. Now, there's a surprising answer here because it makes X thousand chopsticks a day dollars. So therefore, it's going to be in thousands. So it's going to be in thousands of dollars. That's dollars. X thousand pairs. Still got this down to be 18 when I did X dash that. That is a little bit surprising. Because the change here is not 18, is it? Or not even close to 18. Let me just go back to my calculator, just check I didn't do anything daft. 0.0006 times 100 squared plus 24. I can't see what the mistake is. I'll check the answer in a minute while I'll give you a chance to do the next question. So you subtract these two answers away. So what I would do is I now take away this answer. So if I just do mine, it's not going to let me do that, is it? Go down. Let me do minus. No. So okay, just do shift answer. Normally when you do that, it just puts the answer in automatically for you. So now I'm going to do 12,959,800, and I get this answer. So it's going to be 12,959,39398 point that. Don't really need that number. So it's going to be basically 129,594. Just going to check the values I'm putting in once more. This is what you do when you're not happy with your answers. I'm not happy, so you can tell I'm not happy with this answer because they're not really anywhere near each other. That's 18 and this is 129,000. And that should be the rate of change at that moment in time. And it should be reasonably close. It should be reasonably close. It won't be exact, but it should be reasonably close. I'm just checking. I've got 3 noughts there. And I've got 3 noughts on the 6. And I've got squared. I've got 3 noughts on the 2 in the cube. That's the answer. Oh, I've done times 54. There we go. See, could see that I made a mistake. So this is quite lucky for you. This is how to know you've made a mistake. I was expecting these answers to be reasonably close, and they're nothing like each other. Okay, they're nothing like each other. So now press execute. I get 7,600, which is for this one. 7,617.9 will do. Put a decimal there, not a comma, because that means some decimal. And now what I'm going to do is I'm going to go back up and put 100 in here. I get 7,600. There we go. We get a much more reasonable answer, and it's almost identical. 7,600. So look, really good example. Live streaming, made a mistake, found the error without actually having to look up the answers in the book, which is good. And we can see the difference is £17.9. Note how close these are. The rate of change is 18, and actually the actual cost of producing one extra chopstick was 17.9. Okay, so let's move on to question 2. So cost of hour running a barge is given by its average speed. Find the cost of running the barge for 2 hours at 15 kilometers per hour. So we're going to do C of 15 and work that out. So what I'm going to do is I'm going to type 15 in just like I did, because it's going to ask, 2 hours at 15 kilometers an hour. Where V is the average speed. Cost per hour. Okay, so we've got the cost per hour. So we can find C of 15. So let's put that in. And we're just going to do 10 times the answer plus 90 divided by the answer. Okay, that gives me 156. So that gives me the cost per hour. So therefore 2 hours cost will equal 2 times that, which is £312. Part 2. So you've got to be careful here. There's 2 bits to the question. There's the cost per hour with an average speed, and we got the actual length of time as well in the question. So do be careful. Now if I go back up, I can find the cost per hour on 24 just by typing in 24. Changes all my answers. So C of 24 will equal £243.75. So 5 hours. I'm going to probably type that, so times that by 5. You notice I just typed times and it gave me the answer. It used the answer this time straight away because I hadn't scrolled back through it. I get £1218.75. Find the rate of change of cost of running the barge at speeds of 10 kilometers an hour. So the rate of change of cost. So we need to differentiate this. So part B, we want C dashed of V is equal to, well, differentiate that. Well, let's first of all, sorry, what I'm going to do is I'm going to go back. Is for most of you, what you will need, I can do this in my head, but what most of you will need to do is simplify this to 90 times V to the minus 1. Then you can use your formula of times by the power, take 1 off the power. And I'm probably going to have to add in some more space for the question. So, C dash will equal 10 plus, and it's not going to be plus because it's going to be timesing by minus 1. So 90 times minus 1 will give me minus 90, v, take 1 off the power to the minus 2, which is the same as 10 minus 90 over v squared, for those that you know. You don't need to have to do that. This would have been a perfectly good answer here. But at 10, the c dash of 10, we're going to type, because we're going to work this out twice, I'll do that little trick of typing in 10, and then I'm going to do 10 minus 90 divided by my answer, shift answer squared, those brackets. Notice I'm squaring it inside the brackets before dividing it into 90. So I get 9.1. Okay, so the rate of change of costs of running the barge at a speed of 10 kilometers per hour. And part 2, C dash of 6, well, we just go back up. Rather than typing it all in again, we just type 6 and we get 7.5. If we were to put into units, so rate of change of cost, it's just the cost. So it's for every for every unit of speed we change, this will be the change in cost. Okay, and he wants to know at what speed will the cost per hour be a minimum. Now, the easiest way to do these, I think, is possibly for most people to do the graph. Most of the time, when you've got an equation, it's worth typing the equation. Now we're going to use x instead of v. And you probably want to use the fraction button, most of you, over x. And we're just going to draw that and see what happens. Okay, well, that didn't really produce anything. Let's just standardize. Okay, let's think about this. So we're going to have at least 10. We're going to have at least 10 on the y values because we've got 10 times something plus 90 divided by something. So it's always going to be more than 10. And the velocity is always going to be bigger than 0. So let's just change our view window. We're not going to have a velocity less than that. Let's just make this a bit bigger. Let's go to, well, probably not going to have a velocity of a barge much more than 50. Press that. I want to go back. I just want to change exit. Draw. Change my view window. I want to change my Y scale. So I'm not going to have Y below 0, and I'm definitely going to have it more than 10. Put 100, shall we see? Just going to draw that. And there we go. We can see our graph now. And it doesn't really matter my Y scale is 1 unit, even though I'm going all the way up to 100. We can see what's going on. Now we want to find the minimum cost. So go to graph solve, go for minimum, and it tells you when it happens. So the minimum cost, was this part C? And was it the velocity? So min will be when speed is equal to 3 kilometers per hour, I think it was. Let's just check our units, and it's 3 kilometers per hour. So our x value is 3, and my minimum value, the cost per hour, is 60, and it doesn't ask us for that. Now, if you were doing this algebraically, then the minimum is worked out by making the derivative equal to 0. So you could solve this equation. Okay, and let's just quickly just show you how you do that. So I'd get 90 over v squared equals 10. Grab more space. And therefore 90 equals 10 v squared, so 9 equals v squared. So plus or minus square root of 9 will equal v. So, but v can't be negative, so therefore v will equal 3 kilometers per hour is our units. So we see we get the same answer. Now there's no, in IB, because you can use your calculator, you don't need to do all of this. You could just draw off the calculator straight away and get your answer by just pressing the graph solve and getting the minimum value. Okay, question 3. Rectangles inscribed in the parabola y equals 9 minus x squared. If OD equals x, so we've got OD, so we've got that value as x. Show that the rectangle ABC has the area function equal to that. So what we're doing is we've basically got to realize that this is our y value. So therefore the area will equal 2 lots of x times by our y value. Now what's our y value? It's equal to 9 minus x squared. So we get 2x times 9 minus x all squared, which is equal to 9 times 2x is 18x, minus x squared will give me minus 2x cubed, which is the answer. Okay. Now we want to find where this has a maximum area. Let's just exit this. Let's go up here and then let's type in a new function. I'm going to type in 18x minus 2x to the power of 3. Now, here's a tip if you're doing an exam. You might not be able to get part A out. You might not be able to prove this. But you now got an area function. Okay? And you want to find the maximum area. Well, then just do what I'm doing now. Put this area function that they gave you in the end of part A into here. Draw it. We see my little scale. Let's just... What happens if I just do the standard one? It probably won't work either. Yeah, it goes a bit off the scale. It doesn't really matter. As long as we can see some of the graph, it will be able to solve it. I don't need to be able to see all the graph to solve it. If you want to see the graph, you can zoom in a bit and solve it. And we want to find we get maximum area. So press the max button and it tells me that x equals 1.73. So max area is when x equals 1.732 for SF. There we go. And we want to find our y value. So the y will equal 9 minus 1.732 all squared. So, and it actually gives me the y value in here. So actually, let's save ourselves some time and just write out that 20.78 and so on. And it wants us to give the coordinates. So therefore, coordinates, you probably get most of the marks for this, but just in case, we're just going to do 1.73, 20.8 to 3SF. And that's how you do that. So you could have differentiated this, put it equal to 0, solved that equation, and got that out. So if we differentiated this, you'd get 18 minus 6x squared, make that equal to 0. So therefore, you're going to divide by 6. So we're going to get 3 equals x squared when you do this. So therefore, the square root of 3 is equal to x. And that's probably actually a nicer answer than 1.732, is to be able to write it as square root of 3. But you don't need to do that. It doesn't ask us for an exact value. If you ask us for an exact value and you just got this and you haven't got an exact value in your graph, then what I suggest you do is you have to go in and do it properly like I've just done here to find the x value. Right, moving on. Right, what we're going to do is we look at some properties of curves, so tangents and normals. Next, so we want to find the equation of tangent 2. Now, I'll just quickly do it the long way. So we differentiate to find the gradient, because when we've got a graph, we've got minus 2x squared. So if I was to draw a sketch of the graph, I know my graph would look a bit like this. I want to look at the point where it's minus 1, and I've got a tangent that's doing a bit of this. And I want to find the equation of that line there, that tangent, at that point where x equals minus 1. So differentiate this to find the gradient at that point. That gives me minus 4x. So when x equals minus 1, the derivative, or of this, put minus 1 into that, will equal 4. So the gradient equals 4. And we've got y minus y1 equals mx minus x1 is the equation of a straight line. Now we don't know the y1, but we can put it into this equation to find it. So put minus 1 into this. So when x equals minus 1, y will equal minus 2 times minus 1 squared, which is minus 2. So the equation of my line is y minus minus 2 equals the gradient 4 times x minus minus 1. That's the minus 1 and the minus 2 is this point here, the coordinates of where it is a tangent. And that gives me the equation of the whole of that line. I can simplify that if I wanted. That's plus 1 times by 4 is plus 4. And if you want it in y equals mx plus c form, you don't have to. Then you'd get that. Now, that was all the working I'd do if I didn't have this calculator. I go back to this, type in my function, so minus 2x squared, press execute, press draw, press sketch. Now I want a tangent, and I want a tangent at x equals minus 1. And there we go, we got the tangent at that point. Now, for some reason, normally gives me the equation of the tangent. I normally set it up. Go shift setup, go down. Normally graph function, dual screen. Derivative on is usually what you need. Go down, background none, line, grid line. Normally that's enough for me to get the equation line given to me. I go x minus 1. Given me the derivative, but it hasn't given me the equation here. Normally it types out the equation over here, just here. I don't know why it hasn't done that in this case. Let me just see if I can look it up quickly. No, I won't be able to. I'm sorry about that. Well, now what we got the gradient. We didn't have to differentiate to get the gradient. We got the gradient. We know it gives us the y value minus 2, so you can put it all straight into this equation here. And you can jump straight to this point of the problem. Okay? And my one that's not writing, so what I'm going to do, I'm just going to close it for a second and get it back. And scroll down to where we got up to. Yeah, you can see it's now remembered it. So occasionally this app crashes like that. I'm really surprised it hasn't given me the equation. Okay. If I what I might go do is go offline and I'll post another video later to explain how that's got that. If there's anybody in the chat happens to be watching live, wants to give me a suggestion, then they can let me know. So we can do the equation of tangent to this at the point minus 1, 1. Now the problem we're told with the equation is this, so we can't use this to solve that. Okay, because we can't type in this equation into our graph. So we're going to have to do this the old-fashioned way. So we're going to find the derivative, this. Differentiate a, it's a number, it's a constant, so it just goes to 0. Okay. Now we've got a minus bx and minus 2. I'll rewrite this. So I'm going to times by minus 2, so I'm going to get 2b, and take 1 off the power, gives me x and minus 3. So I know that f dashed of x equals 2b x minus 3. Now, we know on this graph it's going to be, if you were to draw a graph, like what you can do to help you is you could draw a graph where you make up an a and a b. So let's just say we've got 2 minus 3, then put a fraction in for you. 3, let's just say b is 3, and we've got it over x squared, just so you can get an idea what the graph looks like. It looks like this. So at the point minus 1, 1, if a and b are both positive, okay, so if we're at the point minus 1, 1, we're going to be having a tangent over here somewhere. Okay. Now we know the gradient of this tangent is equal to the gradient of this curve at this point, at this point here. And the gradient of the tangent, remember this is y equals mx plus c. The gradient of the tangent, okay, minus 6m is the gradient of the tangent. So we know the gradient of the tangent is minus 6. So we know that minus 6 will equal 2b. Now, we're at minus 1, minus 1. So let's put minus 1 into this. So minus 1 to the power of 3 is minus 1. And because it's a negative power, then it's just going to give us -1 here. So therefore 2b will equal 6, so b will equal 3. So what I did here was, I know that my gradient must be the same as the gradient of this at this point. So my gradient of this line is -6. So no, -6 must equal to all of this when x is -1. So put -1 in, put the -6 in, and then I can solve this. So I've now found out what the b value is. Now, once I found out the b value, I know the x and y. I can put them back in to find out the a value. So I know my y value is -1. F of x is my y value, so that's -1, will equal a minus, now I know b is 3, over x squared -1 all squared. So I know that a -1 equals a minus 3, so a will equal 2. Find where the tangent to this curve at 1, 5 meets the curve again. So what we're going to do is, first of all, we're going to just type this equation in. Generally, on all these types of questions, type the equation in and see what the graph gives you. So we've got 2x power of 3 plus 4x minus 1. Okay, let's draw that, and there's our graph. And we want to find a tangent, so let's put sketch, and we want tangent, and we want the x value to be 1. And it's given me my gradient here. So I could do this longhand. Let's just see if they agree. So let's practice our longhand doing this. So we got the derivative is equal to 6x squared plus 4. When x equals 1, we know that dy by dx will equal 6 times 1 squared, 6 plus 4, which is 10. Notice it gives me exactly the same 1. Okay? I really don't know why. Oh, I've got an idea. I just remembered now. Trace. If I do, where is it? 1. Execute. No, I thought that might do it. Tangent. I'm not going to do trace. Okay. Trace 1. Gives me the dy by dx. It. Draw. Sketch. Tangent. X 1. Try one more thing. Draw. Sketch. Tangent. 1. Still didn't give me the equation. I'll have to try and work out. It was doing it earlier. It was giving me the equation over here. That's something you can look up either on maybe somebody else's YouTube channel or such set of instructions as to how you get the equation to show up there. I thought you just had to turn on the differentiation. Anyway, I've got the gradient, so I know that the tangent's going to be y minus y1 equals mx minus x1, where x1 and y1 is a point on the line, so it's 1, 5. 1 minus 5 equals the gradient 10 times x minus 1. So there's the equation of my tangent. Now I want to find where that crosses this tangent again. So what I can do, and let's get the 5 to the other side. I don't need to make this very nice. If you're not confident in your algebra, just do this. And what I'm going to do is I'm just going to type this equation in. So I'm going to type in 10, open brackets, x minus 1. Of course, I would normally simplify that, make that look nicer. Type in that equation, draw, and then what I'm going to do is graph solve and find the intersections of these graphs. So the first one is at -2, -25. Let's write it down, -2, -25. The next one is at 1, 5, which is given in the question. Okay? I don't think there are any more. So, the other point where it meets the curve again, which meets at -2, -25. Okay, So that shows you how you can use your graphical calculator to save you a lot of time and work. Otherwise, what you would need to do is you need to put, if you don't use your graphical calculator, what you've got to do, oops, I didn't want to do that, I wanted to highlight it. What you'd have to do is you take all of that and replace this y here, and then try and solve the equation, which would be really nasty, a cubic equation, which again you can do using your graphical calculator. But what's the point when it already does that for you? Find the equation of the normal to this point. So we're going to go exit. Let's just delete this one. Delete this one. And type in our new equation. So we have x to the power of 3 plus 3x minus 2. And I've just drawn that all in wrong. Keep an eye on what I'm doing. So we've got power of 3. But bring that back down, plus 3x minus 2. Draw, and I get my tangent, my curve. Now I want to get my equation of my tangent, and I want it when x equals 2. Okay, and I've got my gradient. I didn't want my tangent, sorry, I want my normal. Let's go exit, draw. Sorry, sketch is what I want. Not that. Do it again. Sketch, normal. Okay, and it's got the normal x equals 0. Well, we're going to put in 2. Okay, and we've got the gradient of the normal. So the gradient of the normal equals 15. Now, what I'm surprised at is it hasn't drawn that normal. Normally, oh, it's because grade at 2 is way above it, where we can see. Yeah, it's above where we can see. Look, it's gone off the edge of the graph. So there's the gradient of the normal. So we want to find the equation of normal when x equals 2. So we need to find that when x equals 2, y will equal 2 cubed plus 3 times 2 minus 2. Sorry, not plus 2. So you've got 8 plus 6 minus 2, so that's going to be 12. So we've got y minus y1, there's our y1 value. Goes through the y value at 12. Our gradient, m times x minus x1, and our x value is 2. So there is my equation of my normal. I don't really need to do any more than that. That's a perfectly good answer. You can simplify it. If you're a y equals mx plus c fan, then what we do is do 15x minus 30, and then we add the 12 to get 15x minus 18 as our answer. Right, let's do some binomials, and these should be quite easy because we just basically plug them straight into our calculator. So I'm going to go exit, menu, I want to go into stats 2, and I'm going to go into distribution, and I'm going to go into binomial. The school volleyball team has 9 players, each of whom has a 75% chance of coming to any given game. The team needs at least 6 players to avoid forfeiting the game. Find the probability that for a random chance game, the team will have all of its players. So we've got x is binomial, and the number of trials here, there's a possible 9 trials, and the probability of success is 0.75. So basically, we'll look at each trial as a player turning up or not turning up. So does the first player turn up? Yes, no. Yes is 0.75, no is 0.25, and so on and so on and so on. So that's why it's a binomial, because you've got 2 outcomes for each player. Do they turn up or don't they turn up? And we want to do part A, part 1. What's the probability that x equals 9? So we just want an equals probability. So we can use BPD. And we just put in x equals 9. Our number of trials is 9. Our probability of success is 0.75. Press that in and you get your answer, 0.07508. What's the probability for randomly chosen game that will have to forfeit the game? So we want for part 2 the probability that x is less than or equal to 5. So we're going to use the other version. Go into distribution binomial. BCD gives you the probability of less than or equal to. Actually gives you lower value and upper value, so that makes life easier. In the old calculator, you just did less than or equal to. So obviously 0 will forfeit the game, and 5 will forfeit the game. We've got number trials 9, probability, here's our probability, 0.1657. Here's the probability they could forfeit the game. The team plays 30 games a season. How many games would you expect them to win? So the mean for binomial is equal to the number of trials times the probability. In this case, that is going to be, what we've got to be careful here. We've got a new binomial, and this is quite a clever question what they do here. So in our new variable, let's call it y, because the new variable is them whether they forfeit a game or not. And our number of trials is going to be 30, so it's going to be binomial 30. But the probability of success is forfeiting a game is 0.1657. That is our probability of success. And I'm going to write the rest of the digits down here so I can type it in a minute. So let's go and find our well, we don't use this because we just want to find the mean expectation. I'm just going to get my space. So I only need to find how many times do you expect the team to forfeit? Well, the expectation of this is number of trials times the probability. So mu will equal 30 times 0.165757. Go to menu 1 and do 30 times that number. And you get 4.97. So we probably expect 5 games per season. Per 30 days. That's the closest it's going to be. Okay, 4.97 is closer to 5 than it is 4. So we would expect them to forfeit 5 games in 5 of those 30 games, which is not very impressive, really. Okay, question 12. It's observed that 3% of batches produced by a company are defective. Random sample of 20 batches calculate probability that none are defective. So we've got X is binomial, number of trials is 20, and the probability is 0.03 being defective. So we want to find the probability that none are defective. So we want to find the probability that X equals 0 in this case. Okay, we want none of these to be defective. Let's go to menu, stats, go to distributions, go to binomial, go to the BPT because we're doing equals. X is 0, the number of trials is 20, and we've got the probability is 0.03. And you get 0.5437, so on. So in stats, we tend to go one more figure than we'd normally go. So we normally go 3 figures, so go 4 figures in stats and probability. We want, that's part A. Part B, we want the probability that at least one is defective. So probability that X is greater than or equal to 1. Well, if none of them are defective as this, then at least one defective is just going to be equal to 1 minus that answer. So it's going to be equal to 0.456. We could just say 2 to that many figures. Now what we could do is we can check that. I go back to my binomial and go to BCD and go my lower value is 1 and go my upper value is 20. And you notice it gives me exactly the same answer. Okay. One more binomial question. 24% of visitors make voluntary donations on a certain day. The museum has 175 visitors. Find the expected number of donations. So P is equal to 0.24, N equals 175. So X is binomial NP 175 0.24 when you're writing it out. Part A, what's the expected number of donations? So the mean will equal 175 times by 0.24. So menu 1, 0.24 times 175 equals 42. Find the probability less than 40 visitors make a donation. So B, find the probability that less than 40 visitors make a donation. So P of X is less than or equal to 39 or less than 40. It doesn't really matter. You either have a less than 40 or less than or equal to 39. Let's go exit, go menu 2, go to our distributions, go to our binomial. We're going to go B, C, D, and our lower value is 0, and our upper value is 39. Our number of trials was 175. Probability that they will make a donation is 0.24. And that gives me 0.336. Just want to check that. So it's a number makes donations, less than 40 making a donation. So there we go. Just create a bit more space for part 2. Part 1, part 2. Between 50 and 60 inclusive visitors make a donation. It means we're going to include the numbers 50 and 60. So we got 50 is less than or equal to X is less than or equal to 60. So let's go exit. Let's go to lower bound 50. We want to include 60. We want to include, and our answer is 0.0931. Two pretty significant figures. And there we go. That's all we're going to do. On the integration side of things for this test, we've done lots of sheets recently. You can go in and fill in the questions to the ones that we've not completed as extra integration revision. I hope you find that useful for our test. There we go. Those are all the answers to this. I will try and look up that thing about tangents and see if I can get that working.